Hey guys, alright, so at this point you should have turned in your homework, you should get out your notes, and we're going to take some notes and start a new topic. So we are talking about fractions and decimals, and you are not going to use a calculator today. You may want to, but you are not going to use a calculator today. We're going to start off with a couple vocabulary terms. The first one is a rational number. Basically, a rational number is any number that can be written as a fraction. So that includes whole numbers, that includes decimals, terminating decimals, and repeating decimals, which leads us to our second vocabulary term. To write any rational number, like a fraction, as a decimal, you divide A divided by B. Now, what it's basically saying is you do top divided by bottom to get your decimal. And if it was written as a fraction, then it's either going to be a decimal that ends, which is called right here, which is called the terminating decimal. Or if a decimal that repeats, that's called a repeating decimal. So you either have one or the other. When you say, but I got a whole number, Mrs. Schultz, that's actually considered a terminating decimal. It just ended at 0.0. So we've got those are vocabulary terms. We've got rational number, terminating, and repeating decimal. Now I know it says diagram here. We're actually going to skip that, and I want you guys to turn the page. Here we have, how do I turn this fraction into a decimal? And like we just said, any fraction can be written as a decimal through division. Now I'm going to go slightly fast through this because I do know that you guys know how to do long division. At any point, if you guys need to pause it and slow down, please pause this video and slow down. If you have any questions, please feel free to raise your hand and ask the substitute teacher. So number 1, 5 over 11. 5 over 11 is the same thing as saying 5 divided by 11. And so what we would do is we would simply make it into a long division problem. Yes, I know you guys have calculators. No, I don't want you to use them. So we have 5 divided by 11 right here. And as you guys know, we have to fit, how many 11s fit into 5? Obviously, there are none, so that's 0. And then if there's nothing to move over, what we end up doing is we add a decimal point and zeros. Now when we're dividing and there's a decimal on the inside, it actually just gets put up and you still figure out everything the same way you normally would as if there were no decimals. So we're going to keep everything in line just like a normal division problem. We say how many 11s fit into then 50? And you would say, oh, not 5, it's not 5, it's 4. Sorry guys, I clicked the wrong thing. So it was, there are 4 that fit in, and that gets me 44 right here. Then to move on, I use subtraction. 50 minus 44 is 6. And then I bring down the 0. How many 11s fit into 60? That's 5. 5 times 11 is 55, so I write that down there. I subtract, and I get 5. So I write that down, and I bring down my next 0. How many 11s fit into 50? Well, you would say 4, because 4 times 11 is 44. When I subtract it, I forgot to put the number there, but when I subtract it, I will end up getting a 6. And at this point, you should start to see a pattern, because then it'll start saying 4, 5, 4, 5, 4, 5, and it will go on forever. You do not need to continue once you've found the pattern. Since I found the pattern and I realized the 4, 5 is the what repeats, then my answer is 0.45 with the repeating symbol over the 4 and the 5. The line that's over this 4, 5 means a repeating symbol, which basically means that this number is 0.4545454545, and it goes on forever. And that's how that is found, how we change a fraction into a decimal. Now, you will have some, like this one, where it's 7 divided by 20. Obviously, I'm just going to click it all because this is not, there we go. So when I do this division, I'm figuring out that 7 doesn't fit into 20, or 20 doesn't fit into 7, and so I put these zeros here. Once I did that, then I figured how many 20s fit into 70, and there were 3. So 3 times 70 is 60. I then subtracted a 10, brought down a 0, and 5 went in, and it went in exactly. If it ends in a 0, then it goes in exactly, and my answer is simply just 0.35. Now, some of you may recognize that 20 can go into 100, and that is true, because if I change this fraction to be over 100, I can also figure out my decimal that way. We are doing the long division way because we're going to get some that repeat. We're going to do one more here, and again, I'm probably just going to have to click through here to get my answer because it is not showing up. So give me just a minute while I change it so it all shows up at the same time. Here we go. And it should. And now it's not even popping up. Oh my goodness. Okay. Oh, I know why. Here we go. This should fix it. And of course it does not. So, oh, there it is. Okay, so the other one's disappeared, but bear with me. So here's this number 4 of the 1/6, and I divided. The reason why I'm bringing this one up is because if you notice, what repeats is the 6. The 1 does not repeat, and that's very important because when we write our answer, which is also not popping up right now, let's try and, alrighty, this is not being useful for me here. There we go. What I want you to see here is that I don't have the repeating symbol over the 1. It is just over the 6, and that is very important. And you need to make sure that that is what you do. Okay. Next, so again, on this one, you want to make sure that the repeating symbol only goes over the number that repeats. We're going to skip this ordering. And we're going to move on to changing decimals into fractions. Now, mixed numbers like this, you guys should know that we can just put it over 100. So the decimal part of it, anything to the right of the decimal goes over 100. So the reason why it goes over 100 is because there are 2 digits after the decimal. So if I look here, if I highlight it, there are only 2 digits after the decimal, and so then there are 2 zeros in the denominator. And once you get this, you do have to simplify. Even if it's negative, it just stays negative. I can divide the top and the bottom by 5. Number 4, I did the same thing. We put it over 1,000 this time, though. The reason why we put it over 1,000 this time is because there are 3 digits after the decimal. The last digit is in the thousandths place. So there are 3 digits in the decimal, or in the denominator there. And simplified, because we always have to simplify, I can simplify the top and the bottom by 5. And I would get -1 and 181 over 200. All right, guys. Next, I'm going to show you the beginning part of repeating decimals. This is the part that's new that I'm going to need you to really focus in on here. So I'm actually going to take my time and I am going to pause this video and start a new one to make